Welcome. I guess we might as well begin. This is Friday Night at Cary. I'm Bill Schlesinger. Welcome back. Great to see you all again. Tonight we have a rather special treat in terms of our program. Essentially the debut and reading of a book written by one of the writers in the Cary Institute's Writer in Residence program, that being Akiko Busch. We began the Writer and Artist in Residence program about 3 years ago when Rebecca Allen, who was an artist, still is an artist at the Bard Graduate Center down in New York, called me up and said she would like to have a showing here. And I, of course, coming out of a lab science, had never really gotten involved with showings and didn't know what that entailed. But we went ahead with it and found it to be a great event. We paired Rebecca and her paintings that night with Dave Strayer, who then were able to discuss and compare and contrast the contrast between how writers, artists, and scientists, in her case artists and Dave being a scientist, portray the water bodies such as the Hudson River. One using analyses, chemical analyses of the chemistry of the water and perhaps the composition of the fisheries, and Rebecca capturing that with paints. And one of her paintings is right outside the door here of Wappinger Creek that was on display that night and was a gift to the Institute. So it was the success of Rebecca's first visit here that begged the question for me, why don't we do this more regularly? Why don't we have more types of artists and writers and such on a regular basis that can come here and interact with our scientists, hopefully enrich both cultures crosswise. And we've now had 6 of those visitors. Last week we welcomed the 6th, Catherine Larson here from University of Arizona. You can stand up and take a bow in front of everybody. Who's a writer in residence for a couple of weeks here this spring. But we've had an interesting collection of both artists and writers over those 6 people. Now enough of the history, because tonight we're really here to talk about Aki's book and have some readings from it. So this book is really a product of her visit here those few months ago. It's a wonderful little book called the Incidental Steward, which looks like this, and you can see more of them outside. Aki is certainly among a vanguard of those who appreciate and participate in what is becoming increasingly known as citizen science, the ability of everyday citizens to make a contribution to science simply by observing nature, writing down what they see, when they see it, and how many, and when, and that this, if it's done in some kind of organized fashion, becomes a really interesting record in a way in which the public can contribute to the process of science. We're going to have Aki do some readings and talk about her interest and motivation and history of involvement in citizen science. And then we'll hear a little bit from one of our senior scientists, Stuart Findlay, who's sitting next to her in the front row, who engages volunteer citizen scientists regularly in his work in the Hudson River. And Doug Reed, also sitting in the front row here, who is a self-proclaimed advocate of the Hudson River and the founder of the Hudson Basin River Watch, and has himself been involved in lots of gathering of citizen science and these kinds of contributions. So different perspectives and results in contributions. So back to Aki. Aki is a graduate of Bennington College, local writer, lives right here in the valley, whose past books include The Geography of the Home, Patience, Taking Time in an Age of Acceleration, something we probably all should pay more attention to, and 9 Ways to Cross the River, which chronicles her own capacity and tendency to like to swim across large rivers, something which immediately makes me want to sit down and rest. But it's a wonderful little book about swimming rivers, including the Hudson. Her new book, just released by Yale University Press, as usual, will be available outside courtesy of our collaboration here on these book reading and presentation evenings with the Merritt Bookstore. It carries a strong flavor of her interaction with the scientists here during her visit in the spring of 2011. I think you will find the reading with a deep insight, not just about how and why we record the appearance of eels in our streams each spring, but what their presence and their persistence in those streams means in a rapidly changing world. And all of this is through the eyes and the pen of, I think, someone you will agree is a most gifted writer, Akiko Busch.
Thank you so much for that. Such a warm introduction. Thank you so much for inviting me to be here tonight. And thank you even more for the wonderful invitation 2 years ago to come and be in residence here for 2 weeks. It was an extraordinary experience to be able to speak with all the scientists here. They were incredibly generous with their time, incredibly patient with my questions. It was a complete honor and sometimes a revelation, and I'm just deeply grateful to everyone at Cary for all the help and support from okay, so I want to just talk a little bit about citizen science and then read a section from my book. My own engagement with citizen science with these programs came through total serendipity. It began literally with a knock at the door. It was a May afternoon 6 years ago, and an intern from DEC came and knocked on our door to see if he could get our permission to go up to the woods behind our house because he was tracking a radio-tagged Indiana bat that was apparently roosting up there. The bats' summer habitat seemed to be changing, moving northward, and the DEC wanted to know more about this changing migration pattern. So they radio tagged the bats as they were leaving their hibernation caves near Rosendale across the river. And this one bat that they tracked had apparently ended up in our woods, or not our woods, but the woods behind us. Anyway, so I said, of course, absolutely, but only if you let me tag along with you. And he graciously agreed. So we spent the next hour trekking up the mountain, and about an hour later, found the colony, the maternal colony of bats, roosting under the bark of an old black locust tree. The radio signal led us to the bats, but it wasn't. It was probably 4 or 5 in the afternoon, so it wasn't the bats that we saw, but the bats that we heard, or rather bats that he heard. I think I probably would have missed it altogether if he hadn't said stop and listen. But if you stopped and were very still and listened very carefully that May afternoon, you could hear this kind of distant universe of sound, this kind of soft click, hundreds of soft clicking sounds that indeed signaled that the bats had taken up the roost up in the locust tree. And then he took out his data sheet and he wrote down where the tree was, what kind of tree it was, what condition the bark was in, the canopy. He took all the details down so that over the following summer, crews could come down from the DEC and do exit counts. That is, see how many bats there were leaving the tree in the evening and keep track of how many there were and what they were up to. And I realized that this entire enterprise required a kind of attentiveness, a kind of tuning in, a kind of attention, watchfulness that was really something I wasn't very skilled in doing, and I began to be interested in that. And as so often happens, you make a decision like that, and then one thing just kind of leads to another, and it led to mornings on the Hudson River looking for water celery. It led to tagging along with a naturalist who was in January doing the midwinter bald eagle census count. It led to helping count the herring and the eels that come up to the Hudson River's tributaries every spring. So one project just kind of led to another. And I found myself engaged in this thing called citizen science. I just want to talk about what that is for a minute. Rick Bonney, who was an educator at the Cornell Lab of Ornithology in the 80s, came up with the term. And the Cornell website, and a lot of it started there, not all of it, but a lot of it started there. The website at Cornell describes it as projects in which volunteers partner with scientists to answer real-world questions. That's a good definition. It's broad, but you can go even broader. Judith Eng is the Region 2 administrator of the EPA, and she defined it to me as anyone using a tool focusing on scientific measure or portrayal. And as an example, she showed a film that these two guys in Brooklyn had made from their window overlooking the Gowanus Canal, and there was this flood, this wall of raw sewage washing down the canal after a heavy rain, and these guys filmed it and put it on YouTube, and she said these guys are real citizen scientists. So you can see the definition right now is very, very broad. My own feeling is that keep it broad, that's fine. The whole enterprise is in such a nascent phase that to have a broad definition is fine. We can narrow it down later. But however you think about it, non-scientists collecting data for scientific research, I think continues an American tradition in naturalism. Henry Thoreau's records of what bloomed when around Concord continue to be used today by scientists who are studying warming temperatures. Franklin Roosevelt kept field notebooks of bird arrival dates, and those are used today also by scientists who are studying climate change and changing migration patterns. So I think it's part of our legacy, and we're just continuing it. But I think citizen scientists today are continuing it in a different way, and they're different from their predecessors in several ways. I just want to quickly outline those. First, I think there is a growing sense of urgency. Al Gore famously said that watching the evening news is like taking a nature hike through the book of Revelations. He said it. And I think so, whether it's a warming climate or habitat loss or a burgeoning human population of 7 million plus, or any number of other things we could all itemize, a sense of urgency is driving many of us. It seems as though catastrophes of our own making are befalling the natural world, and so this kind of motivates a lot of us to get engaged in these programs. The second is new technologies, GPS, internet databases, interactive websites, mobile phone apps. All of these facilitate getting, I think, somewhat reliable research and disseminating it and collecting it and getting it out there. The third thing is I think it makes sense at a time when the scientific community is ever more stretched financially to use volunteer labor. And then the final thing I think is citizen scientists today are likely to work in a more collaborative way. I think naturalists in the past, the study of nature has often tended to be a solitary enterprise, whether it's Thoreau and his cabin by the pond, or John Muir's walk to the sea, or Aldo Leopold's shack by the river. The study of nature tended to be done in a solitary way, and I think that's really changed. Last winter, when the snowy owl migrated from the Arctic down to the lower 48 states in unprecedented numbers, their numbers were cited and reported on eBird, allowing birders to share the information and generate broader public interest and knowledge. So no surprise then that there are today hundreds of these participatory programs around the country where volunteers can help collect data on everything from migrating monarchs to jellyfish to coral reefs to ice melt, you name it. I think it was Thoreau himself who said, "Every poet has trembled on the verge of science." I mention this because in the projects I was involved in, I found unexpectedly that there's much more of an intersection between the sciences and the humanities than I had ever expected or that I had known about. And I found that we sometimes even work in the same spheres of knowledge. The poet Wallace Stevens once said that accuracy of observation is the equivalent of accuracy of thinking, which is not so different from the message I got from many of the scientists I met with and went out into the field with. And I think this is really important. I think especially at a time when the disciplines so many of us work in are so specialized, this idea of convergence was interesting to me and worth pursuing. And also at a time when scientific literacy is at such an all-time low, it was interesting to me that there were these intersections I found. Rick Ostrick is a geologist who educated me in the properties of Mile-a-Minute vine, which is a non-native vine that's kind of running rampant through Jackson Creek out in the Grange where we live, and just doing real damage to the banks. And he said to me at one point, he said, "Science is just the best available knowledge that we have at any one time," which comes very, very close to the way I've always defined poetry. So what was clear to me as well in all of these outings is that there's probably something universal in the human impulse and desire to take measure, whether it's counting eagles as their populations restored in the Hudson Valley, or counting the eel and the herring that are migrating into the tributaries, or just measuring rainfall and keeping track of temperature. There's something about this impulse to keep track that I think we all share. There was something amazing to me in finding that aquatic geologists who are researching climate change and warming temperatures in the northern hemisphere look to records kept for 500 years by Shinto priests in Japan on Lake Suwa. The holy men kept track for centuries of when the ice froze and then when the first crack appeared on the surface of the lake, because it was their conviction that that crack indicated that God had put his foot there. And there's something about these two separate interests coming together with the same interested or passionate about the same information that was amazing to me. So it became hard for me not to think that this instinct or desire to take measure is something we all share and it's innately human. Certainly I found that in the people I met when I got involved in these different citizen science projects. Certainly I found it in a IBM manager who had been laid off, who used her administrative skills in documenting the vernal pools in northern Dutchess County. I found it in the work of a Catholic priest who was obsessive about mowing and otherwise trimming, taking care of the invasive vine that was strangling the woods outside his church. And I found it in the words of a sophomore from Poughkeepsie High School who was involved in the eel program, counting the eels as they came into the fall kill in Poughkeepsie. And she said, "I'm going to know more about eels than you ever knew was there." Yeah, she was great. So all of these projects really offered a kind of template for attentiveness. All of these participatory programs, I think, generated a kind of awareness that can, I think, at the best of times, further the partnership between scientific research and public knowledge. Certainly that was true when I assisted in taking inventory of the water celery beds on the Hudson River. Getting out there to look at the water celery is a great excuse to spend the morning on the river in a kayak. But when that information that you get reflects measurable facts about water quality, then the connection to the river goes a little bit deeper. So I want to read a short section from my book about those mornings up the Stockport Flats looking for the water celery. But I'm just going to tell you a little bit about water celery first, then I know Stuart's going to tell you the real stuff, more about it, but just a couple of things. Water celery is subaquatic vegetation that occupies about 6% of the river from Haverstraw Bay to Troy. Where the plant grows, where it proliferates, varies over time, but it's a tough perennial, but salinity and marine traffic and pollution and various other things can work to diminish it. So taking measure of the wild celery beds is a way of taking measure of the river's health and the health of the ecology of the river. But calculating its whereabouts poses real practical problems. Every 5 years since 1997, aerial photographs have been taken of the water celery beds, just to kind of map out where they are. But the photography is costly, and it's limited in what it can tell you. It can capture the outline of the bed, but sometimes the glare, it obscures the image, and the photography also can't tell you how deep the water is, and it can't give you any information about water clarity. So, and the beds vary in their growth and density, so you really need something more than aerial photographs. So to find out more, Stewart established a program in 2003, and now every summer he and David Fisher worked with some 20 of us kayakers and canoers to send us out there, train us in data collection, send us out there to kind of take stock of what's happening in the river. And so we go out equipped with these maps marking transects and waypoints, location coordinates, along with these handheld GPS units that help to locate the coordinates. And then we go out in pairs to find these beds. One of the things I found in this project, I found in a number of these projects, and I don't think it's limited to people practicing citizen science, is that this enterprise sometimes requires reconciling two different kinds of information. In this case, it's an exercise in trying to reconcile what the satellite imagery or digital imagery, or in this case, aerial photography tells you, and then what you see with your own eyes, what you witness, what you experience, what's there, which is in science called the ground truth, and by extension, in my mind anyway, the air truth and the water truth. But I think this is something we're all called upon to do outside of citizen science, and that is reconcile what the digital world tells us with what we experience ourselves, whether it's on a social networking site or in some other area. I think it requires a use of the creative imagination that we perhaps have not been called upon to use before. And I think at the best of times, these two bodies of information can mutually inform and sustain and support one another. It doesn't always happen, but in the best of worlds it does. So that was interesting to me. So I'm just going to read a short section about that from the water celery chapter in the book. They do this great thing here at the Cary. They really try to train you. They really try to, you really have to know what you're doing. And so in the workshop, before we go out, it's a few weeks, it's in the beginning of the summer, they give us these GPS units, these Garmins, and then they put us through this exercise, and they give you these coordinates, and then you go out to the parking lot, and you find the coordinates, which means, you can find the place you're looking for. You can get to the place the scientists want to know. What's the water celery doing? So, you get this exercise, and, you find the, it's you go to the hemlock near the parking lot, or a car or a sign, and you think, this is great. I know what I'm doing. And then a few weeks later, you go out onto a moving river, and everything's different. So I'm just going to read a couple of pages from that section. At a training workshop earlier in the spring, I'd done my best with the Garmin to find arbitrary waypoints at assorted locations next to the Cary Institute's parking lot, under the spruce tree, over by the edge of the road. The frustrations of that afternoon were nothing compared to those experienced in trying to identify a waypoint on moving water. Water changes everything. Stewart has said as much at the training session. Getting the data is 25%. 75% is just getting there. And I now saw what he meant. With the pull of the tide and the current, the faintest surface breeze, the inevitable drift of the canoe, or any of the other elusive factors that figure into the way a boat passes over water, the GPS coordinates were fugitive at best. What happens out on water follows a less direct flow line. A surface wind on the river was enough to remind me that how we know where we are and gauge our position is always an elusive exercise. Small wonder that the data sheets ask that we document both the expected and the actual locations. It's not just the coordinates that were hard to pin down. The river world is always ambiguous, and for the proliferation of all the water weeds this time of year, for all the acres of spatterdock spread out across the flats, and the wide beds of water chestnuts, the Stockport Flats are a curious place to take inventory. The river here has been completely reconfigured, engineered, and re-engineered from dredging decades ago. Continually washed by 4-foot tides, the islands, flats, and marshes are the result of dredge spoils, where the shallow water areas of the river were recontoured in the 19th and early 20th centuries to accommodate large ships traveling up to Troy and Albany. Within only a few feet, the depth of the river here can change abruptly from 4 inches to over 30 feet. Out in the channel, it's deeper yet. But where we were laying out transects, the river went from shallow to shallower and back again. The tide only added to the changeable boundaries of river and flats. One became the other quickly and constantly, and the contours of what was solid and what was fluid, what was water and what was ground, were constantly changing. Surely it was folly to imagine taking measure of such a place. By the second transect then, we were out of our boats and waiting. The river here was 4 inches deep, too shallow to paddle, and Doug got out of his canoe and just pulled it along, wading between the waypoints. For all the clarity of the water and brilliance of the afternoon light, trudging through the shallows along the meadow of mudflats and spatterdock was a clumsy exercise. Along with the orange buoys, we were equipped with a secchi disc, a black and white circular form that's lowered into the water on a string marked off with centimeter markings. Determining how deep the disc can be lowered into the water before it's no longer visible is a way to measure clarity which can be affected by sediment, precipitation, and wind stirring up the water. But with no place for it to go, the disc stayed in my kayak. Several dark shaded patches on the 2007 aerial photographs had suggested the existence of water celery on this spot along the river. A vague triangle or blurry linear strip might indicate an area of growth. But the images were laid over one another, square over square, in an overlapping vertical arrangement that was oddly static and had little to do with the wide continuum of the river, seamless and ceaseless on a summer afternoon. Not for the first time, I wondered about the wisdom of trying to match up the natural world with such obscure digital images. Doug laid out the third transect, but still nothing. The data sheets offered a range of choices for the density of the beds: none, sparse, average, dense. And I continued to write none, none, none. But none, I knew, is still data. 0 can be data too. I'd heard the statement more than once, and it's a good lesson. When we don't hear anything or see anything or say anything or think anything, when we have nothing to go on, that too is information. This seems to be a known fact that transcends the boundaries of discipline. In music, silence can be as resonant as sound. In mathematics, 0 can have the authority of a number. Robert Ryman's white canvases are a primer in the richness of empty space. Merce Cunningham's choreography, an inquiry into stillness. Waiting for Godot, one of the most celebrated plays in the English language, is famously described as the play in which nothing happens. And in the words of abstract painter Ellsworth Kelly, the negative is just as important as the positive. Absence can be as powerful as presence. And so we headed downriver, and though there was still no sign of the wild celery beds, Doug spotted a cormorant with a strand streaming from its beak. With its long, curved neck, the double-crested cormorant is graceful and goofy at once, and this one appeared to be floating downstream with a smug satisfaction at having come upon the celery before us. That's what's happened to all the wild celery, Doug sighed. The cormorants have eaten it. It's a new theory. Let's leave it to the scientists to figure out. You always say that. Let's leave it to them to figure out. Not until the fifth transect did we finally spot the watery tendrils, and then suddenly they were everywhere. Where they brushed the surface of the water, they lie flat, combed by the current in an infinite variety of patterns. But beneath the surface, their dense growth was even more apparent. Now, as my kayak slipped across the water, it made a soft, rustling sound. We'd found what we wanted, where we wanted it, and when. An alignment, a desire, expectation, and discovery that I recognized to be infrequent. Wild celery puts its roots in the riverbed, but its leaves grow as slender ribbons, no more than 1/4 inch wide, but up to 7 feet long. If the water is dark and visibility low, it's easy to miss them altogether, to paddle across the bed and never know they're there. Looking closely now, though, I could make out there the empire of strands, a vast submerged spreadsheet of the river's health. The water had a different texture here. There was something in the exercise of locating transects, about calling out the location numbers. It seemed to be a way of assuring ourselves that there is an order to what's happening out here, a way perhaps to catalog and identify the unseen. But the ribbons drifted and flowed in whatever way the current combed them, marking out a different, more tenuous transect. By now I knew what ground truths were and could identify their equivalents out here on the water. Water truths by nature seem to be transitory and elusive. Thank you. I'm now going to turn this over to Stuart.
So Stuart Findlay, senior scientist here at Cary, and organizer of many of the volunteers and citizen scientists, will offer a few comments. What is that one?
Okay, well, thank you all for coming out on a very pleasant spring evening, and thanks to Aki for that description of her book, which I hope you'll all take a look at. It's a lovely book and describes a variety of this sort of experience. And also, every time I talk about this project and the use of volunteers to collect data, I always thank the volunteers. So Aki and Doug have both been engaged in this for a long time, and there's at least one other volunteer. Henry Woods is there. Thank you, Henry, almost from the beginning. And I'm not sure if there are any of the other volunteers here this evening. I didn't catch them. But anyway, Peg. Thanks a lot to all of you. Let me switch over here. What I'm going to do is talk a little bit about sort of exactly what is accomplished from a science point of view by these dedicated volunteers. As Aki said, this idea of using citizens to get science done is relatively new. By and large, it's embraced, but there are occasionally problems that crop up, such as consistency and acceptance of the data by regulatory agencies in particular. I'm happy to say that the experiences I've been involved in, there's never been a question about sort of quality of data. But there are things that come up once in a while. And watching out for those ahead of time is very valuable. And at the same time, you have to appreciate what is this citizen science contributing to the project as a whole. So the submerged aquatic vegetation on the Hudson has been going on for about 20 years, and the volunteers, as you heard, for about the last 10 years. And one of the things we try and do when we're speaking with volunteers, either the ones that have done it before or new folks, is make sure they understand what the whole project is about. As you heard from Aki and you'll hear from Doug, there are some pretty specific things that they're asked to go out and do and data to collect and observations to make. But we feel it's very, very important that they understand the bigger picture. Why are we doing this in the first place? We could have picked something else to go out and look for and document its occurrence and distribution. And being able to understand what these plants do, how they might change, and again, just why we care about this is pretty important. So the project as a whole deals with the inventory, so what's there, and this is largely where the volunteers come in, as you have heard and will get a sense. We also care, what do the plants do? There is good evidence that we've collected that it's important habitat for fishes, it contributes oxygen, there are indicators of water quality, as Aki already spoke about. So the plants do important things, and that's a separate set of observations that have been made. And we've also learned that these plants are extremely dynamic. And you get a sense of that from Aki because we give the volunteers places to go to tell us plants are there or not. And those coordinates are places where plants were present at some previous time of photography. And it turns out sometimes they're not there anymore, or they've shifted around. So understanding the change is pretty important. So understanding the whole point of the project, I think is very important for the volunteers. Gets things done right, and also gives them a sense of, how is this all contributing. So what the volunteers do, as you've already heard, is they do, to some extent, confirm the air photo interpretation. In the beginning, we thought that was the most important thing. Turns out that documenting the change that occurs between times of air photos is probably more important. These plants, again, are highly dynamic. It's not as though they stay in one place and they're guaranteed to be there every time you go out to look. The field observations, and I'm going to give you just a couple of examples of what they do in the field that we cannot do otherwise, and it's things like what are the species present. From the aerial photography, it just looks like shadows in the water. And I'm happy to show you some of these photos later. The interpreters are really good, and they see things that I can't see, but when you go out there, it turns out they're actually mapping the right stuff. They can tell us about how dense the cover is, which you really can't get from the photography. And they talk about water depth. They can give us information on water depth. These plants are very much limited by how much light they receive. And so, as I'll show you in a few minutes, it's relatively small differences in water depth make a huge difference to these plants. And so differences across years in how clear the water is makes a huge difference to these plants. So knowing that water depth and light penetration is quite important. As you've heard from Aki, and you would probably hear from the other volunteers, being ambassadors for the river is very important. You would get a sense from being out there, you probably get a sense from listening to Aki talk about it, that the actual practice of going out and putting down these points where you're going to do your observations and paddling around searching for the proper coordinates. I've done it myself. It looks a little comical because there's lots of going in circles. There's lots of backtracking. There's lots of, I'll call it, heated discussion between the two partners about whether they're going the right direction or not. By and large, we don't let spouses go together. It turned out not to be such a great idea. And so it generates interest from people that are watching, just what the hell are these people doing out there? And so being able to talk about, what we're doing is not just, circling around aimlessly. We actually have a purpose. We're trying to, document what's out there, and there are reasons why we're doing that, so they can speak to the interested public about what's going on in their river. The active volunteers are also very good about recruiting new volunteers, and that's word of mouth is largely how we get our new volunteers. Each year there are about 20 volunteers active, and overall we've had roughly 50 participants since we started doing this. So Aki describes this in her book, and this looks really simple as far as what's actually done. So in a map like this, the bright green is the water celery that's actually the target of what we're looking at. This is the Esopus Meadows area, just south of Kingston, north of Hyde Park. And so there will be a mapped area, bright green, 2007, supposedly there are plants there. And we will lay out a transect, and there are points on that transect, and the idea is on the river to go out there and go to those points, say, I'm at the right place, and write down what you see. Sounds like a piece of cake. You think it's easy, I'll tell you when the training day is, you come out and try it. It is way, way harder than it seems. But we give folks places to go and get them the right training and equipment so they can get out there. And our success rate on getting people to the right place is, I'm sure, well in excess of 90%. So it does work. These folks work incredibly hard. It sounds like a great way to spend the day, and it is, but you have to realize there are serious time constraints because you can only go at low tide, and you can't go if the weather's been particularly bad. Depending upon how good you are finding the points, how strong the currents are, or how strong the wind is any particular day, it really affects how many points you can get done. Since we started, they've done in excess of 2,000 points, which is way, way more than we could ever sort of generate the funding to do. If we had to employ people and have them go out and collect this amount of data, broadly distributed up and down the river, all the way from the Troy Dam to Haverstraw Bay, there's no way we could sustain this kind of effort. But the volunteers do it. You'll have to ask them why they do it. I'm not 100% sure. So you can ask them afterwards why they do it. Doug may touch on that. So it's an amazing amount of number of observations that are made, and these are very useful. And I'll just touch on a couple of the findings that we get from the work they do that would not be obtainable otherwise. So this figure deals with the water depth issue. So up the y-axis there is how deep the particular observations are made, and whether or not plants were recorded as being present. So the box up here are observations where no plants were present, and on average that was in about 1.4 meters of water, which is only about that much, so not terribly deep water. You go to just somewhat slightly shallower water, and all of a sudden plants are present, so they start showing up at about 0.9 meters of water, which is only about that much. So the difference between where they're present and absent is about half a meter, which is a little over 1.5 feet. So not a very big difference in water depth as to whether or not this particularly valuable habitat occurs at a place or doesn't. And only from the volunteers going out, recording whether the plants are present, and recording directly water depth, can we get at this sort of thing. So we now have a really good idea of where plants ought to be, and we don't necessarily go looking for them in 2 meters of water, because it's extremely unlikely that they will be present. And without the people out there doing this diligently and consistently and correctly, we wouldn't know this sort of thing. The other big thing that turns out to be probably the most important thing the volunteers do is they catch changes that occur between years when we can do aerial photography. The photography's been done just about every 5 years, and we always wonder, what's happening in the intervening years. You could not do the photography every year for a whole bunch of different reasons. And what the volunteers have enabled us to do is catch changes that occur, and I'll just mention one sort of rapid and large change that occurred in 2011. This was Hurricane Irene, Storm Irene, combined with Lee. The images on the right show the amount of water coming down the Mohawk River and the turbidity that came along with it. So given the magnitude of the event and the likely effect on water clarity, which we knew was bad for the plants, we strongly suspected that 2012, after the hurricane, was not going to be such a good deal for the plants. And we could not do aerial photography on such short notice, but fortunately we were able to ask the volunteers to go in 2012 back to the same locations that they had visited in 2011, which our view was this was the most sensitive and precise way of detecting any changes that occurred. So these are observations that were done in 2011 before Irene, and something like 40% of the sites that were visited reported plants as present, so positive findings. 2012, the volunteers went back to exactly the same points, and again, they have to write down exactly where they are, so we're sure that they're at the right place. And there were only 2 reports of plants out of about 100 observations. So clearly, good documentation using consistent methods that there was a widespread loss of plants from the river. I'll just tell you now, we don't know exactly why this happened. We could talk about that after the program. There are a bunch of hypotheses that have been put forward. None of them really hold up. So if you have a new one, we can talk about it later. So as always, thanks to the volunteers that do this, I hope you've gotten a sense that the information we have could not have been garnered any other way. The volunteers have a good time. They do work hard. It's fairly challenging in some respects. And I just want to touch on a couple of things from Aki's book, one of which she mentioned and one of which she didn't. This idea that negative findings are just as valuable as going to a site and having water celery leap out of the water into your kayak. This is what science is about, is sort of falsifying your hypotheses, being challenged because you don't see what you expect. It really makes you think hard that maybe your view of the world is not right. And Catherine was talking to us at lunch, and she came to essentially the same method. Don't get too comfortable in what you think you know, because the world will very likely surprise you. And so that's reflected in what Aki spoke about in several places in her book. The second thing that comes to me from reading her book is this appreciation for variability. The world is a constantly changing place. Right now it's changing pretty quickly, but it's a constantly changing place. And the challenge for us as scientists is not to throw up our hands and say, well, every little spot is different, or every little spot will be different 5 minutes later if I turn around. That may or may not be true, but the challenge to us is finding the sort of consistent patterns. The general principles will let us understand what's going on, while at the same time appreciating the dynamic nature of much of what we see around us. So the passage she read was actually pretty good about this and appears other places. But appreciate the variability you see around you. That's what makes the world an interesting place to look. But also look for the commonalities, because that's what's going to let you take action and move some things forward that we probably need to do. So with that, I'm going to stop and turn it over to Doug, who's been a stalwart volunteer, I think since the very beginning, best of my knowledge. And I think Doug will explain sort of the real truth about what goes on out there on water.
Can anybody hear me? It is on. Okay, that's good. Well, this is show and tell. So show and tell. Thank you, Stuart. Before I start reading my notes, I'd just like to say it's been a pleasure working with Stewart for a long time now, because of all the Hudson River scientists and speakers I've heard, Stewart has a wonderful way of explaining things simply and with a good sense of humor. I totally appreciate it as a citizen scientist. And Aki, discovering your interest in the Hudson River later, and what a wonderful writer you are. These are two vocations I wish I could practice as a specialist, but I'm right in between and I'm enjoying every minute. So thank you, Aki and Lori, Stuart and Bill, for inviting me here. I'm grateful for the opportunity to speak to all of you about my experience with the SAV program. It's been great from the first workshop right to each and every day on the river, which probably amounts to 12 days in 10 years. I mean, that's all it was. But it's a much bigger memory. It's been rewarding in remarkable and surprising ways. But first, I'll get to what it's like being on the river. But first, I want to tell you where I come from in the sense of place and in the sense of perspective. The place is Cambridge, New York. It's about 110 miles north of here. Peg and I just drove down a couple hours ago. It's on the northern edge of the Hoosick River watershed, which comes out of Vermont and Massachusetts into the Hudson near Hoosick Falls, and is a major tributary of the Hudson River. We look at it every day. The perspective is from the position right in the middle of Hudson River citizen science, between the citizens and scientists. I helped create and lead a project we called Hudson Basin River Watch in the early 90s. Our mission was to improve the water quality of the Hudson River and all its tributaries through education, community involvement, and stewardship. No small mission, and with great success, with many high schools, environmental groups, water resource agencies. We trained and developed a network of over 100 Hudson Valley teachers, environmental educators, volunteers, citizen scientists, and thousands of students. We helped develop and coordinate the first 5 years of the day in the life of the Hudson River estuary. And I hear that our program was a model for New York State Department of Environmental Conservation's statewide volunteer stream evaluation program they call WAVE, which stands for Waitable Assessments by Volunteer Evaluators. This is a huge shift from the early 90s when I started an internship with DEC. They wanted nothing to do with volunteer stream monitoring then, but times change and people too. I understand their hesitation about working with volunteers, as I'm sure Stewart and others did when they started the SAV program. There's enough variables out there already without adding some anonymous and anomalous citizen scientists. So what's it like to volunteer for the SAV program? When Stuart and Jeannie Barnaba, the first outreach coordinator from Cornell, asked me to recruit from our Hudson River Watch network, nobody responded. So I volunteered myself, half out of curiosity. How are they going to do this? How will they coordinate a diverse group of unknown volunteers, and how will they use the data? And I also volunteered half out of the thrill of looking at those fantastic aerial stereographic photos of the Hudson River, and what a river it is. The training sessions, both classroom and on the water, are short and to the point. After we've all completed our surveys, we gather at a Hudson Valley restaurant to go over preliminary results of the season and have fun trading stories. All these meetings establish great camaraderie. Stuart, David Fisher, and the Cornell team are excellent volunteer coordinators. They knew how to do it, and I learned a tremendous amount from them. I think we volunteers, though, responded in kind, and we kept pushing our levels of performance on the river year to year. Here's a typical day in the life of 3 volunteers. Aki, my wife Peg, and I at Stockport Flats, where Kinderhook Creek and Claveret Creeks drain into the Hudson, about 5 miles north of the city of Hudson. We start weeks ahead checking tide charts, picking a day with 4 somewhat convenient hours of daylight to bracket the low tide in order to complete a survey of 30 to 40 target points. On survey day, we load boats, gear, food, water, drive to the launch site, and get out to the first transect as soon as we can. It's always a leap from land to water, from casual terrestrial to globally positioned satellite-focused observations through moving, mostly opaque water. But we get into it quickly. The field data sheets with the transects and target locations and 6 columns for data entry, presence, absence, depth, water clarity, and the last one just notes. That's Aki's job. In her splashy blue plastic kayak. She's very good at it. Peg drops the Secchi disc, which is this cool looking thing. Made it very simple, black and white. When it disappears, you mark that depth, and that tells you water clarity, right? Very easy, and we have the line marked at meter points, so we can just read it quickly. But it drifts down the river this way, that way, depending on the tide. Nothing's easy out there. And this is the trusty GPS unit, and I just put that on the boat and watch numbers scrolling back and forth. There's 14 numbers going through there all the time, and when it matches the point that they put on that data sheet, I drop this thing, and it unrolls quickly to say that depth and stays there. This little sinker just anchors it. So we mark a whole transect with, say, 5 or 6 of these, turn around and go back and do the data observations that way. And they should line up straight. I don't think I've ever seen a straight line of 6 of these. But they're close. They're close. They're not across the river somewhere. So Peg is helping me navigate this so-called straight line. I'm dropping that orange marker, all the while watching the channel for traffic and the shoreline to see where am I going. And we don't get much of a break in 4 hours, except between the transects. There's a couple of 100 meters when you go to the next site and you have a moment, many moments, which linger for days and nights afterwards, and then merge into some timeless realm that I've really grown to treasure. Like this email that Aki sent me after one fine volunteer day in 2009. She wrote, I'll just start in the beginning. Out onto the river at 8 a.m., approximately 2 hours before slack, expansive beds of trappa framed by hedges of spatterdock and pickerel weed, cormorants skittering along the river, great blue heron motionless in trappa bed, snowy egret in the mud flats. And then at the end, this is 11:30, tide coming in fast. Keep the boat still while making notes. I nose it into a trappa bed. Otherwise, the upstream drift is too quick, and I'm swept away. It's a real struggle to get back. Very hot. We are tired, feeling cramped. 5 egrets are on the mud flats. When we paddle by, they suddenly are aloft. We are in a Japanese painting or a poem. Doug says it is like sudden snow in August. How do you identify what is going on out here? Locate and identify the transects? Follow a ribbon of water celery? A sudden upheaval of snowy egrets? So thanks for the memories, Aki and Stewart. You and the SAD partners, all of us, it's just, you're the best. Thank you.
I think if you guys are all willing, you could have a seat at the counter here and take a few questions from the audience. We won't have this persist for terribly long because I know people have places to go and things to do. But I'm sure there's things that popped up in people's minds that they'd like to hear about. I'm going to turn this over so you can pass it back and forth. Grab one from wherever. Curious thought process over here.
I'm not clear how you measure depth.
Good point. I did not bring my 6-foot meter stick. You just jab it in until it hits the bottom and it's marked. Okay.
So the measurements of depth are a low tide measurement, is that correct?
Yes, or
So
close.
when you're saying it grows in such and such. But what is the variation in those beds? Is it, I mean, in high tide, it must be quite a difference.
And we don't go out at high tide. I don't think you can see it because the tide is 4 feet.
Yeah, so I think the question is the tide range is about 4 feet. And once it gets, deeper than close to low tide, you can't see what's going on. So that's one of the restrictions.
How far along the Hudson do you work from home? To the lift right now?
Wait.
Sit there.
Obviously, is water salary considered overall a good thing for the river? I pass on the train sometimes, and I'm not clear of the distinction between water salary and water chestnut, but I thought that what I was looking at the window was somehow kind of suffocating or flying on here. Can you clarify that?
Yeah, so what you're seeing from the train is water chestnut, and that is an exotic invasive species, and it does sort of blanket the surface bright green. And it has some negative effects. It also has some positive effects, but that's what you're seeing from the train. Water celery, if you're not there at exactly the right time, almost looking straight down into the water, you won't see it as a casual observer. It's actually fairly difficult to observe.
And it's considered a good
And
thing.
it's very definitely a good thing for the river.
Back there.
You said you've been watching this for about 20 years. What kind of changes have you seen in the water cellar, where it is? Is there more or less? Do you have, some...
Well, until the hurricane, the hurricane really appeared to take it all out for some reason. So we're very curious how it's going to come up this year. But until the hurricane, there had been a slight decline, but not huge. And what was really striking is how quickly it came and went from various locations. So So there would be places where we had observed it present for years in a row, and all of a sudden it's gone. It's gone for 2 years, and all of a sudden it's back. So highly dynamic, sort of blinking in and out at specific locations. So overall, across those years, a slight decline. And then after the hurricane, a precipitous decline, which I'm convinced it will recover. How long it's going to take, we'll have to see.
And maybe one more?
Do the measurements take into consideration what effluents are being put into the Hudson at various points and the effect that has on vegetation?
Yes, they do. So when we started looking at how dynamic the changes were, we had a number of hypotheses about what might be causing those changes. And the location of sort of human impacts, be it boat launches, boat traffic that's not good for it, or the wastewater plants. We tested both of those, and neither one turned out to explain where plants were disappearing or reappearing. Interesting. So in a way, that's a good news answer, because we are doing much better with our wastewater management than we used to do. And so it's nice to be able to say it's not causing a problem. We don't get to say that very often.
Well, thanks to Stewart for getting this off the ground scientifically a few years ago. And Doug, you've been with it from the beginning. And Aki, special thanks to you tonight for producing such a wonderfully written little book on your experiences, not just on this project, but with fields of birds and bats. I guess it was a coyote in your backyard. I mean, all of which makes delightful reading, and to have that appear just in the last week or two out of Yale University Press in such a wonderful little volume to hold and to read. We thank you all for delivering that on the world with your own prose and your own way of describing it. It's so delightful. So let's give the panel. Doing my job if I don't talk about our next Friday night program, Friday night, June 7th. David Rothenberg, an author of a newly appeared book called Bug Music, How Insects Gave Us Rhythm and Noise. I think I saw that reviewed in the Wall Street Journal a few days ago. And it should be a delightful program again here on Friday night, June 7th. David Rothenberg, hope to see you there. Thanks for coming.